So by the fundamental theorem of algebra, guys, this will have 4 roots because the highest degree is 4. So tell me, how many roots would just simply x cubed have? 3. How about 2x plus 1? How many roots would that have? 1. And how about 3x to the 5th plus 2x plus 3? How many roots would that have? 5. The fundamental theorem of algebra says that the highest degree polynomial will be the number of roots you have. Okay, so we're going to do a couple more stage review problems. Now, it's been a long time since we've done these. That's why we're doing this. Now, remember, if you're taking good notes and you've titled them stage review, I'm going to reward you in some way, like giving you a higher percentage on what you got or something. So I'm probably just going to give you a 5% increase on that score, on your stage score, and then if you do the packet that I'm going to try to come up with, then you'll get an additional 5%. That's a huge thing, guys. You could get a 10% increase on your final score. But you've got to be proactive in that. It's a choice, and you've got to make the right choice, okay? So be taking good stage notes. Make sure you're keeping them all in the same place. Okay, so we're asked to divide 4x squared plus 23x minus 16 by x plus 5. So remember that we learned to divide many different ways. So you could try it by doing a couple different things. First of all, you could set it up like this. You could do 4x squared plus 23x minus 16 all over x plus 5. And then you can see if the top factors. And if it does, then you can divide out common terms. Or if it doesn't factor, though, you're in trouble because this still divides. So do you guys remember learning long division and synthetic division?
Yeah.
I'm not going to go over long division because you can always use synthetic division. So I'm just going to use synthetic division. It's really quick. We're going to review that, and once you see it again, you'll be like, oh yeah, that was super easy. Now I can divide any polynomial because synthetic division is not too bad. But the important thing to remember with synthetic division is that you look at your polynomial here, and you've got to make sure it has every single degree. So we're going to be putting down the coefficients. So the coefficient in front of x squared is 4. The coefficient in front of x is 23. And then the constant coefficient is negative 16. Now, if we were missing, like for example, if we were missing the 23x, we would need to put a 0 there. So we need to make sure we have one for every single x value. Does that make sense? Okay, so now we're setting up our little box thing here with our coefficients of the polynomial. And then we're going to put on the outside of our box our root. So you always do the opposite of what this is. So the reason behind it is the root of x plus 5, if that's a factor, if x plus 5 is a factor, then we can set our factors equal to 0 and solve for the roots, right? So we would subtract 5, so x is equal to negative 5. So we've got to put a negative 5 on the outside of our box here. So if they give you on the stage, if they say a root is this, you won't do the opposite sign. But if they give you a binomial, you've got to solve for the root. Does that make sense? Okay, awesome. So let's go ahead and do our synthetic division. So remember, it's always adding straight down. And so you add straight down, technically there's a 0 here. So pretty much we're just dropping down the first term. 4 plus 0 is 4. Then you multiply 4 times negative 5, which is negative 20. Then you add straight down. 3 times negative 5. Negative 15, and adding straight down.
Oh no, sorry,
negative 31. Okay, so then you start at the very bottom of your list here and you work your way up. So this must be our remainder. If that's our remainder, then this is our constant value. If this is our constant, then this is our x. So this polynomial becomes 4x plus 3 with a remainder of negative 31. So did it divide into it evenly? No, we have a remainder, but we can still divide it. So, okay, let's do another one like this. But it's going to be asking something different. So it's the same idea, asked something different. So it says, is x plus 3 a factor of x cubed plus 5x squared plus 11x? If it truly is a factor, then we will have a remainder of 0 because it will divide evenly. We can still divide it, but it will divide evenly if that's truly a factor of this polynomial. So let's use synthetic division. Let's go through it to find out if it's a factor, and let's see if our remainder is 0. If the remainder is 0, yes, it truly was a factor. So once again, let's set up our box here. Let's write down our coefficients. So on the outside, we have a 3, then a 2, then a 1. What do we need to not forget about right here? There's not a constant, but we've got to put in a what for that? a 0. So we've got to put in our plus 0 here, pretty much. Okay? All right, so now we're going to write down our coefficients. We have a 1, then a 5, then an 11, then a 0. If you don't put in the zeros where you're missing a value, you're not going to get the correct answer. We set up our box. Now, what are we going to use to do our synthetic division with? Very good, -3, because we set the factor equal to 0 and solve, so we will get x is equal to -3. Oops, -3. So we're going to put a -3 on the outside of our box. Okay, then you always drop down the first term here, so we'll drop down your 1. 1 times -3 is -3. That's what goes up there. Add straight down, we get a 2. 2 times -3 is -6. We add straight down. And then 5 times -3 is -15. We add straight down and we get -15. So this is our remainder. If that's our remainder, then this is our constant. If that's our constant, then this is x. If that's x, this is x squared. So this polynomial became 1x squared. So I'm just going to write x squared plus 2x plus 5 with a remainder of -15. So did it divide into it evenly? So it's not a factor. We could still divide it, but that's not a perfect factor of that polynomial. So the answer on this one would have been no. Just because we have a remainder. Okay. Any questions on those? Okay, moving on. This will be our last stage review problem for today. So make sure you read the problem because you don't need to do all this extra stuff. It's just like you've got to figure out what it's asking you. So it says, given the zeros of the polynomial, what would the factored form of the polynomial look like? So given these zeros, given these roots, what would the factored form look like? So we have x is equal to 5, that's a root. X is equal to 3i, that's a root. And x is equal to the square root of 2, that's a root. Are those the only 3 roots we have? No. Who said no? You're right. You're right. Okay, can you tell me one extra root we need to put in there? Okay, awesome. So since this is an irrational number, we know that the conjugate root theorem says if we have a rational root, then its conjugate is also a root. Good job, Shad. So we also have x is equal to negative square roots of 2. That's also a root. Its conjugate is also a root. Anything else? Yes? Good, and the conjugate root theorem also states if you have an imaginary root, its conjugate is also a root. So we also have, I'll write it down here, x is equal to -3i. How about x is equal to -5? No, that's not an irrational number, and that's not an imaginary number. Now what if you're like, how do you know that's an irrational number, Miss Christensen? You would type it into your calculator, the square root of 2, hit enter, it's going to give you a decimal. Try to change it back into a fraction, because irrational just means it can't be written as a fraction. So if you type in the square root of 2 into your calculator, you hit enter, and then say math fraction enter, it's going to just give you a decimal again. So does that make sense? It can't be written as a fraction. If it could, your calculator would be able to do it. All right, so now let's write out the factored form of these. So if these are the roots, then we've got to bring everything over, so these are each set equal to 0. So I'll do it in a different color. So I'm going to subtract 5 from both sides. So we have x minus 5 is equal to 0. We're going to subtract 3i, so we'll have x minus 3i is equal to 0. I'm going to add 3i, so I'm going to have x plus 3i is equal to 0. I'm going to subtract the square root of 2, so I'm going to have x minus the square root of 2 is equal to 0. And I'm going to add the square root of 2, so I'm going to have x plus the square root of 2 is equal to 0. Now we're just working backwards here. So now the zero product property rule allows us to split these things up and set them each individually equal to 0. So if that's the case, then we can bring them, since they're all equal to 0, we can bring them back together. So this would be the factored form. X minus 5 times x minus 3i times by x plus 3i times by x minus the square root of 2 times by x plus the square root of 2 is all equal to 0. That is the factored form of the polynomial. Now luckily this question didn't ask us to multiply it out. That would have been a nightmare. You won't have something that hard on the stage, but you very potentially could have something like this. Does that make sense? Okay, awesome. All right, let's move on to the new stuff for today. Now the exciting thing is we're getting into our statistics unit. The cool thing about statistics is a lot of people really like it because the math is really easy. It's pretty much adding and subtracting. So statistics, a lot of people go into it that like math because it's the math behind it's really easy. But the truth is, we're going to just be seeing a lot of new words. So you're going to have to know a lot of new definitions, and it's going to be like a totally different language, okay? So yes, every lesson you're going to learn crazy new words, but the math is going to be super easy. So with that being said, you need to pay really close attention to what I'm calling things. Or else when you get to the test, it's going to say, find the measure of central tendencies. And you're not going to have any idea what that means. But really, finding the measures of central tendencies is super easy. It's just adding and subtracting. But you get what I'm saying. You're going to have to know what things mean. So it's a whole new language, so take really good notes, and you'll be fine. Study your notes, you'll be fine, okay? But like I said, the math is going to be really easy, so that's kind of exciting. So today we're going to be analyzing data in a statistical way. So we're just breaking into statistics for the first time. And there are tons of statistical ways for us to look at data and kind of make decisions based on that data. So today we're going to focus on measures of central tendency. So that sounds all fancy. Measures of central tendency. It's not that fancy. All it means is that we're going to be looking at the middle of our data set. So we're going to be looking at the middle parts of our data set. And there's different ways of doing that. We can look at the mean, the median, and the mode, and the range. We can look at these three things. They're all measures of central tendency, just different measures of central tendency. So you guys have done the mean, median, and mode before, and range in your past math. Let's quickly just remind ourselves how to do this. So mean means average. So once again, mean means average. You're finding the average. A little trick to help you remember these. So if somebody calls you average, you're an average teacher or you're an average student. That's like really mean. You're like, no, I'm awesome. So that's a way to remember what, if you see the word mean, then say, okay, I remember when somebody called me average and that was really mean. So then you remember, okay, mean means find the average. So to find the average of your data set, you're going to add up the numbers. So I'm going to do my sum sign because that means add, right? Sum. So we're going to get kind of cool right now. So that is our sigma sign. That just means we're going to sum up our data set. So we're going to sum up our data. We're going to add them all up. And then we'll divide it by the total number of data points. So that's how you find the average. You'll sum up your data, you'll add them up, and then you'll divide it by the total number of points you added up. The median. Median means middle number. So you're just going to put them in, it's really important that you put them in numerical order from least to greatest, and then you're just going to count in and find the middle number in your data set. Now, a way to remember what median is. When you're driving on a road, a lot of times in these big cities they have a median in the middle, right? To make sure that you understand that one side of the road or the next. Median is the middle of the road. Does that make sense? So middle point. So just make sure your numbers are from least to greatest, and then you'll just count in and find the middle number. So if this is a point, and this is a point, and this is a point, our middle number would have been that point. That's all it is. Now what if I was to add an extra number in here? What if there is two middles? So for example, this would have two middles. To find the median, you'll sum those two numbers up and then divide by 2. So really you're just going to find the average of those two numbers. So once again, you would add up those two numbers and then divide it by 2 to find the actual median, the middle. Any questions? If you have to, just sum them up, divide it by 2. Then mode. Mode just means the number that occurs most often. That's how I still remember it to this day. Mode means most. It happens the most. So that will help you remember, hopefully, what mode is. So it's just the number that occurs the most. Most sounds like mode. Okay. And then range. Range is just you'll take your largest number in your data set subtracted by your smallest number. So your biggest, your big minus your small. I'm just going to kind of write it short and simple. You'll take your largest number and you'll subtract it from your smallest number. That's how you find the range of your data set. Okay, so you guys know how to do this for the most part. I just want to show you one quick thing and then I'll let you work. Just because the way you're going to see your information is going to look a little bit more advanced than you've seen probably in the past. So look up here at my table really quick and then I'll let you work, okay? So looking at this table right here, it says here's the numbers in our data set, and this is the number of times those numbers occur. So we're a little bit more advanced now. We don't need to. You can, if you need to, you absolutely can rewrite this. There's 1, 1. There's 1, 2. There's 2 3s. So really there's a 3 and a 3 here. Does that make sense of what this is saying? And there's 1, 4. There's 2 5. So really there's a 5 and a 5. And then there's 1, 9. But we're a little bit more advanced than that. We don't need to rewrite it. Unless you do, that's totally fine. But I'm going to quickly just find the mean, the average. Remember, mean people will call you average. So mean means find the average. So we find the average by summing up the total number, the total amount, and then dividing it by the number of data points. So we're going to sum up, there was 1, 1, so we're going to sum up 1 plus 2 plus 3 times by how many 3's were there? So we could either do 3 plus 3, or I'm going to just do 3 times 2. Remember that 3 plus 3 is the same thing as 3 times 2. Multiplication is just repeated addition. Okay, so I'm just going to do 3 times 2 because there was 2 3's, plus 4, plus 5 times 2 because there was 2 5's, then plus 9. I'll sum that up, and I'm going to divide it by the total number of points. Now remember to be careful because there was really 1, 2, 3, 4, 5, 6, 7, 8 in our entire thing. So if you do that, then you're going to get, you sum up the top and then divide it by 8, you're going to get 4. So our average, our mean is 4. Now median would be the middle number. So median will be the middle number. So the middle for this, most of us are at the point where our brains can think about this without actually rewriting this. If you need to though, no shame in that. Just rewrite them out. 1, 2, 3, 3, 4, 5, 5, 9. And then go through and find the middle. But most of us can go through and say, okay, 1, 1, and then there's, so 1 and 1 would be 2, right? 2 in. Everybody's okay with that. And then 1, and then 1 in here would be 2, right? So then 1 more in here, we'd still be here at 2, right? Then 1 in here, we'd still be here. So then the middle is going to be between 3 and 4. 3 and 4, right? That's our middle number. So to find the actual middle number, you'll sum up 3 plus 4 and then divide it by 2. So you will get 3.5. So our middle number would be 3.5. So then, I didn't say this. I need to go back and say this too. I didn't say this. So mode, you know how I said mode is the number that happens the most? If there's 2 numbers that happen the most, or if you have more than one mode, that's okay. It's just going to be called bimodal. So looking at this one, our mode would be, this one happens twice, this one happens twice. So it's bimodal. So we would say our mode is bimodal, and it is 3 and 5. So if these were all ones, we would have no mode. Does that make sense? Bimodal versus no mode. Okay, so now you'll do these problems. You'll do 1 through 3, and those should be pretty quick. We need to move on to the new stuff. This isn't really new to you. So we're going to be moving quickly today. So here we go. Finish up 1 through 3 efficiently but quickly. Done. So this is the first time you're going to see the word outlier. So now we're kind of building on our knowledge with measures of central tendency, which just means the middle of our data. So outliers, they're a value that is substantially different from the rest of the data. These outliers, because they're so substantially different from the rest of the points in the data set, they're either going to be at the very bottom of your data set or the very highest of your data set. They're either going to be at the extremes because they're extreme values. These extreme values that are off the wall, they're not like everything else. And these outliers can kind of be misleading because they so harshly affect your measures of central tendency. So I kind of like to think of outliers as liars. So they're kind of, I mean, that's exactly what they are. They kind of lie because they make your data set look a certain way, but really it's not because those are liars. They're extremely different. So, like I said, they affect your measures of central tendency so much that they're kind of a lie. I'm going to show you an example so you get a better idea of what outliers are. So here's our first example here. So really, the biggest thing with outliers, guys, is just to remember they're extremely different than the rest of your data. So they're extreme. So looking at this, guys, now you can just look up here if you'd like for this example. If you want to write it down, you can. But I won't mind if you just watch this example. So that you can see how outliers affect so much. And this will give you a better grasp of why outliers are being considered, okay? So as a teacher, I can only keep my job if my students average an 80% on the SAGE test. True story, okay? So here are the students' scores. Okay, this isn't really a true story. I made it up. But it would be cooler if it was. It'd be cool if it was a true story. But they do look at teachers' stage scores. Okay. Anyways, so as a teacher, I can only keep my job if my students average an 80% on the stage test. Here are the students' scores. So let's say I had a really small class. I only had 7 students. So this student got a 14%. This person got a 75, 68, 93, 98, 70, and 82% on the stage score. Now, can you tell from these data sets which one's extremely different than the rest? 14%. That's extremely lower than anything else here. There's nothing even close to that. So that would be our outlier. So outlier. So let's find the mean, the average. Remember, mean people call you average. So we're going to find the mean of this so that we can see if my average, if I get to keep my job. So let's go ahead and find the average. So you would do 14 plus 75 plus 68 plus 93 plus 98 plus 70 plus 82, and you'll divide it by the number of students, the number of scores, which was 8. 1, 2, 3, 4, 5, 6, 7. Okay, 7. So if you do that, I'm not going to make you guys take the time to do it. If you do that, you're going to get 71, so that is equal to 71.4%. So do I get to keep my job? No, but let's think about this. Is this really fair? That 14% is very much different than the rest of my scores. Obviously, that student didn't study a dang wink in their life. Does that make sense? So, don't you think it would be smart for the principal to look at these scores and say, that 14%, there's nothing even close to that. That student didn't study, or they didn't do anything. They didn't come to school. They slept through class, whatever. So they throw that out and then find the average. So let's actually find our mean, our average, our true mean. Let's find it without the outlier. So let's find the real average here. I mean, it depends on who you ask. The principal might say, no, that is your average. But it just depends on what you're looking at, okay? So it depends on what you're looking at and what you're talking about. But if I was the principal, I would look at this and say, okay, I'm going to find that teacher's real average here. So I'm going to throw out the outlier, and now I'm going to find the average. So 75 plus 68 plus 93 plus 98 plus 70 plus 82% divided by, now there's only 6 points. If you do that, then you're going to get 81%. So really, in all reality, wouldn't it be more fair for the teacher to actually keep their job? Yeah, the teacher's doing a dang good job, so it'd be unfortunate if they let them go. Okay, any questions? Do you guys now see why outliers can affect your data so very much? Isn't it crazy just that one person's score affected me 10% points? That's crazy, right? So that's why outliers are considered in statistics. So it's really cool. So now you'll do problems 4 through 5 and 12 through 13. They're just going to be asking you to look at your data sets with your outliers, without, and kind of getting you to decide on some things. So go ahead and do those problems. I'll give you quite a while to work, so make sure you show your work too so I can give you full points. Alright, so now we're going to dig a little bit deeper with range and with kind of medians. So you guys have heard of box and whisker plots. That's what really we're getting into, but this is kind of the idea, and we're going to peel back the layers of what a box and whisker plot is. So first of all, when we're talking about range, we know to find the range of this set of data, you'll take the largest number in the data set and you'll subtract it from the smallest number in the data set. And then we know that the median, just like if you're driving down the freeway, the median, or down a road, the median is the middle of the data set. So I'm giving you an example here so that you can see how box and whisker plots work. So box and whisker plots dig deeper into range, and they dig deeper into median as well. So if this is our data set, I'm just doing like a visual example of how these box and whisker plots are made. So in general, this black line, let's say that's our data set. So we know if we count in and we find the middle, the median, meaning the middle number, you could cut it right there, that's the middle number, right? Let's say that little tick marks are median. Well, now we have this front lower half, this set of numbers in this front lower half. We have this upper set of numbers in this upper half. Well, couldn't we now find another median within the lower half? Couldn't we count in 1, 2, count in 1, 2, for example, and find the next median? Okay, so we could find another median. Couldn't we find the median of the upper half, count up 1, 2, count down 1, 2, and find another median of the upper half? Yes, we could. And if we do that, it's going to form our box and whisker plot, because we are going to now just draw in a box Connecting those three things there. So then this would be considered, so it splits it up into quartiles. So I guess I should have left it, I'm going to keep it color coordinated here. So this was our median and this is our median. Okay. So then this was our median. Okay. So from here to here, if this is our lowest point, from here to here, that would be considered, this point right here would be considered quartile 1. So you will want to take note of this. That's quartile 1. It's going to split this up into 4 quartiles total. Then the data sets from here to here, the middle, very, very middle would be quartile 2. Then the next median from here to here, this would be quartile 3. And then in all technicality here, from here to here would be quartile 4. But on our box and whisker plot, we're just looking at the box for the most part. We're focusing on the box, so all we need to write is quartile 1, 2, and 3. Okay? So then this box and whisker plot is made in this way. They just find the middle number, then they find the middle number of the lower half, the middle number of the higher half, and then the lowest point will be your it'll possibly be your outlier. It might not be your outlier, but it could possibly be your outlier, and most likely. And then your very, very highest value, so this will be your lowest value, and this will be your highest value, and it could possibly be your outlier. So notice here, this box and whisker plot is formed because we have our box, which contains quartile 1, quartile 2, quartile 3, and then our whiskers are formed by this is more of our data, this is our lower point, this is more of our data, this is our highest point. So the whiskers kind of connect your outliers, or your lowest and highest point. So that's how a box and whisker plot is made. Now with the box and whisker plot, you might be asked to find the interquartile range. So interquartile range. And all you'll do is you'll take quartile 3, where you're at with quartile 3, and you'll subtract off quartile 1. So you'd be able to look at your data set, and I'm actually going to show you how to use your calculator to do this, but you could do it by hand, right? You could count in, find the middle, on the lower half, count in, find the middle, right? Upper half, count in, find the middle, and then take your highest minus your lowest. Does that make sense? I am going to show you how to use your calculator. We bought these fancy calculators for a reason. So I already drew this for you on the last thing here. But just make sure when you're actually drawing in box and whisker plots, you do need to label it quartile 1, quartile 2, and quartile 3. And once again, if we wanted to find the interquartile range, that means Q3 minus Q1. So let's learn how to get out your calculators, turn them on. Now you need to follow me very closely, if not you're going to get lost. And it's so hard for me to teach you how to use the calculators if you get behind. So let's slowly go through how to use our calculators to make a box and whisker plot. Get out your calculators now so you can follow me through this, guys. So this is what we're going to, it says using the calculator, we're going to use a calculator to make a box and whisker plot of these data set points. So 12, 11, 15, 12. Now write this down real quick because I'm going to pull up my calculator and it's going to unfortunately cover this up. So you're going to want this so you can learn how to use your calculator, and then the rest of the worksheet's pretty quick with box and whisker plots because you'll just use your calculator. Well, you need to know how to use this. You need to write these down. 12, 11, 15, 12, 19, 20, 19, 14, 18, 15, and 16. Now we could go through by hand while you were getting those down, and we could go 1, 2, 3, 4, 5 in 1, 2, 3, 4, 5. So we know this is our median, our first median. Then we could go in 1, 2. We could go in 1, 2. So that's our Q3. Does everybody understand that? Is everybody following me by hand if I'm going to do it? So that you can do it by hand if you need. So this is Q2. And then we're going to find the median, the middle of the lower half. So that would be in 1, 2. And then excluding that in 1, 2. So this would be Q1. So that's by hand how you can find the, does that make sense? Q1, Q2, and Q3. So then the end of our data set would be 12. So this would be our point 12 on our box and whisker plot, just saying. And then this would be our point 16, our highest point on our box and whisker plot. We're going to use our calculators, but by hand, if you had to, that's how you could find it. All right, so here's your calculator. This is how you'll do it. So follow me through, because if you get behind, stop me, because it's going to be really confusing otherwise. There's a few things we have to do here. So the first thing you're going to do is hit your stat key. Does everybody see the stat key right here? Hit the stat key, everyone. Now it should say edit. So you're going to hit enter so that you can edit. Now we're in list 1. Check and make sure your thing, it says list 1 at the top. If not, you need to reset your calculator so that you can be freshly starting. Does everybody have a list 1? What do you have? Is it a different list? Like, is it list 2?
I don't know what's going on.
So once again, guys, if you're in, you'll do second stat plot. Make sure that you're in list, that you're hitting enter here. You're hitting enter. Then make sure it's on. And then make sure you've picked the box and whisker plot. So you'll just scroll down, hit enter on all of those. And then you'll get out of that key. You'll go back to the home screen. So I just did second quit. And then I did zoom. Just hit zoom and then hit number 9. Or scroll down to number 9. Okay. So now what you can do is just hit the trace key. Right here's your trace key. If you hit trace, then it's just going to tell it for you. So now notice, since I said trace, our very first median is 15. That's Q2. Q3 would be 19. So that's the middle of the upper half. Then we have Q1, which is the middle of our lower half. So unfortunately, like I said, when I did it by hand, I didn't do it right because I didn't put it in numerical order. And then our lowest point is 9, and our highest point is, let's scroll over, our highest point is 20. Now, I'm going to go ahead, now hopefully you guys can see that on your calculator. I got to get out of here so I can draw my box and whisker plot. So are you guys all good? So you can tell me where we're at. I just want you to watch me draw this because I'm not going to make you draw it to scale. I'll let you just draw in a box plot that looks pretty accurate and then put the actual points. But watch me, because I promise you on an end of level, on the stage, on an ACT, they will draw it to scale. So this is how you would draw it to scale, because they might even just give you a blank thing like this and say, draw, because you can click and stuff with this stage. They would say, draw a box and whisker plot, you know what I mean? And then you'll have to drag and click, things like that. So watch, right here. On our box and whisker plot, you're going to have to be doing it on your calculator. So what was our very lowest point? My box and whisker plot didn't, oh yeah. Does your box and whisker plot say 11? I think I had a different data set in there. Okay, so what our lowest point was, yeah, I must have typed mine in here. Okay, so my lowest point was, you said 11, right? So this is 10, 12, so this is 11 right here, right? So I'm going to go up and put my point. Does that make sense? Now, what was my Q1? So this was 11. My Q1 was 12, so that would be like right there. Sweet. What's my Q2? 15, so that'd be in between there. So I'm going to write a 15 just so that we can keep track of what we're looking at. And then what was my Q3? So that'd be in between there. So 19. So that'd be right there. Now I'm going to draw in my box. And then I'm going to write Q1, Q2, Q3. And then what's my highest point? 20. So that would be right there. Then connect your box with your whiskers, connecting all of it together. That's all you have to do. Does that make sense, everyone? Now, I'm not going to make, like I said, guys, I'm okay with you guys if you draw it as accurate as possible, not putting a scale down here, as long as you know how to draw it to scale. I'll let you just go, like I would have been okay, now you guys will freehand it, just draw it in, as long as it looks pretty accurate to what your calculator looked like, as long as you write out what this is. So you would have said 11. Does that make sense, everyone? So you would have said 11, then you would have said 15, and then you would have said 19, and then you would have said, oh, right here was 15. Wait, and then what was this, 12? 12. Does that make sense, guys? But you just make sure you know how to draw it to scale if you needed to. And then this was 20. And then make sure you do Q1, Q2, Q3. This is how I'll let you draw it, as long as you specify what those points are and this. But remember, if you had to draw it to scale, you could, because you would just find the correct point on your scale and put it in, right?
You just draw it out like that.
I'm okay with you guys drawing it out like this. Yep. Okay. All right, so once again, do your box and whisker plot, see if the problems you'll do. Now, they might ask you to do a box and whisker plot with the outliers and without. So, so you can either just do two separate, just go with that. Here we go. So do those problems.
It's not letting me choose.
So just remember, if you're going to do this by hand instead of a calculator, let's say you don't have a graphing calculator, just make sure that you put it in numerical order before you find the Q1, Q2, and Q3. So this is correct in how to do it. These numbers are not correct. We've got to put it in order from least to greatest before we actually do the Q1, Q2, and Q3. So just make sure you do that. That I do here. Okay, so now we're going to learn about percentiles. So a percentile is, I'm not even going to read this top one because that just makes it confusing, but what a percentile is it shows the percent of data that are less than or equal to X. So if we say, okay, so I'll just show you the example really is the best way, because percentile, once again though, it just shows the percent of data, so the number of points that are less than or equal to the percent that you're talking about. So if X is at the 63rd, so let's say if some number is at the 63rd percentile, then 63% of the data are less than or equal to X. So basically you're just saying like, you're going to say, I want the 63rd percentile, so you'll find 63% of the number of data points, and then you'll subtract that off. So let's just really, that was a lot of words, it would be better just to show you by example. It'll make sense once we do one example. So looking right here, once again, if you want to just watch, that's fine for this, and then you can practice it on your own. So it says, these are some math midterm test scores. Now look up here, luckily, these are in numerical order, starting from least to greatest, so I don't have to worry about doing that. But if it wasn't, you would need to do that, okay? So it says find the 20th percentile. So it just means 20%, we want to find 20% of the data, and that's what we're looking at here. So find the 20th percentile. So first of all, to be able to find 20% of that amount of data, we need to know how many total data points are in here. So if you count them up, there's I'm counting, there's 20. Okay, I wasn't really counting, but I'm just showing you what I'm doing. So there's 20 data points. Do you guys understand that? So we need to find 20%. There's 20? Yeah. That's what, yes, there's 20 because I counted them up, right? Do you get what I'm doing? Okay, so then we need to know 20% of 20. So how will we do that? Oh, did I say 20? Yeah, I did 20. Okay, so I'm going to have you do it. I did 30 on my paper. So we have 20 data points. What's 20% of 20? So to find 20% of 20, guys, you're going to multiply 20 by 20%, which would be 0.20. How many data points is that? 4. If you do 20 times 0.20, that's 4 data points. So you're going to count up, the 20th percentile will be 1, 2, 3, and 4. So you would say 65. Does that make sense? Yeah, they do have to be in numerical order. Then it says find the 65th percentile. There's 20 points, so 65% of that, you'd have to do 20 times by 0.65, which is 13. So if we want to know the 65th percentile, I'll do it in a different color. We're going to count up 13 numbers. That is 65%. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that is, did I count right? Did I skip anything? That is 82, yeah. I counted up 13. So that would be 82. That is the number at the 65th percentile. Now, but you got to realize, though, it could ask it differently. It could say something like this. What values fall in the 65th percentile? If it asks it like that, that's not asking the 65th percentiles. The actual 65th percentile is asking all the numbers that fall within the 65th percentile. So with this one, you've got to write down all of those numbers that fall within the 65th percentile, which first of all you found was 13 values. So you would write all those values up to 82. Does that make sense? The different way it asks. The values that fall within the 65th percentile versus the 65th percentile, yes.
You have to put them in numerical order before you do it.
Yes, you do have to put them in numerical order before you do it. Yep. All right. Any questions on that? Any questions on that? All right. No questions? Okay. Well, now you'll do 10, 11, and 15 through 18. So basically, you're going to finish it up now. So you're going to finish this up. You will have it done by next time. Do not do this as homework. If you don't finish it in class, take it home and finish it up. We're going to learn as much new wording next time as we did today. So this is all going to jumble together unless you have this stuff down.